Okay, so chapter 2, section 3, we'll review subtracting real numbers. Always a short review for you guys because you're so strong already with subtraction, right? Okay, so Rachel, pick a number, any number. 5. And we will talk about subtraction. So we're going to subtract another number. Give me a number, Wesley. 3. 5 minus 3. So this is something that we're really comfortable with, right? 5 minus 3. And that difference is? 2. Okay, but we will do what? I mean, let's make this more interesting. This would equal 2, you're right. How about if we did this? 3, let's switch these numbers. 3 minus 5. And you probably know already, and you have really good number sense. You're thinking of how it would look on a number line and how you would travel, which is really good. But what is our little rule that we would use in this case? Bella? Good. So we're going to change subtraction to adding the opposite, right? So instead of 3 minus 5, we have 3 plus negative 5. And now we can apply the rules we learned about addition. When we have numbers with opposite signs, what do? Subtract the smaller absolute value from the larger and give it the sign of the larger absolute value, right? And so your sum here is, everyone? Negative 2. That's it. Okay, so probably if you got that question, 3 minus 5, you would just quickly say negative 2 because you have such good number sense, right? But when we get to some trickier things, we will continue to need to use what we've learned about subtracting. Add the opposite. Rather than subtracting, we add the opposite. So in the form of a rule, who can finish this rule? Rather than A minus B for all real numbers, we could say what, Tatum? Well, actually, we're going to leave the order as it is. That would add another thing in. That's actually an equivalent statement, what you just said. She said, oh no, you said B plus negative A. That's not an equivalent statement. How can we just show adding the opposite using this rule? Good job. Okay, so A plus negative B. So we're looking at the term that's being subtracted as a negative term. In algebra, we simply combine like terms, and we always look at the sign preceding the term. And this is A and a negative B. That's what we're combining, A plus negative B. Okay, so negative 2 minus 7. How could we write that, Sophia? Good. And now we fall back on our addition rules. We have 2 negatives, so we simply, and we get negative 9. We add them and we give them the negative sign. Good. How about when we're subtracting a negative, right? What do we say? So 11.7 plus what? Plus negative 5? Plus positive 5? Plus negative 5? What's it going to be? Is it going to be negative 5 or positive? I mean, can we change 11.7 minus negative 5 to 11.7 plus negative 5? And we have the same statement there? Subtracting it and adding it is equal? Right? Is 4 minus 2 the same as 4 plus 2? So we can't just change the operation, right? We always have to change 2 things, right? So it will be what? Positive 5, good. So now in this case we have 2 positives now. So let's say it together, the sum is?
16.7.
Together, 3, 2, 1?
16.7.
Okay, good. And how about with fractions? We have 1/3 minus 1/2. Sterling, what are we going to do here? Okay, so what would the common denominator be? 6? And so what will the first fraction become? Good, so you multiplied by 2 over 2, so there it is, 2, 6. And this one you multiplied by? Good, 3 over 6. So rather than subtraction, we will do what? You can never just say rather than subtraction, we will add them. You have to say we will add the opposite. Change and change. Two things going on there. If we change the subtraction, we must change the sign. Okay? So what do you have now then? What is 2 plus negative 3? So positive or negative? Which one's got the greater absolute value, 2 or negative 3? Negative, so it's negative 1 over 6. So recall that with fractions, we have that like denominator, and then it remains the same, right? We simply add or subtract the numerator, okay? Evaluating change. So if I say that this morning it was 67 degrees, and it's now 80 degrees, what's the change? What are you doing there? If it went from 67 to 80 and you're asked to evaluate the change, what operation are you using, Abby? Subtraction. Good. So when we deal with real world topics and you are asked to find the difference or what is the change, often we are dealing with subtraction. An example of that might be when you buy a brand new car. When you buy a brand new car and you drive off the lot, and then let's say you change your mind, now, a day later, when you sell the car, is it a brand new car? It feels brand new still, but really when you sell it, it's now a used car, second-hand car. So you might be asked to calculate the difference in the value of a car. I mean, what was the change? Look at this. This example here shows that a car was $15,000 when it was purchased, and a year later it's $12,300. So what was the depreciation? Depreciation means the change, usually, well, in a negative way, right? It's going down in value. If something is depreciating, it's going down. Does anyone know the word for when the value of something goes up? Rather than depreciate, it is, right, with an A, appreciate. Like I appreciate you. It's a positive thing, right? It's going up. So we'll be graphing depreciation and appreciation later this year. But right now, if you're simply asked what is the change, then you're simply finding the value, the difference between these two, right? And so, Bella, what would the change be?
2,700.
Okay. And so how did you do that?
You would, you line up to 15,000, and then minus 12, and 300, and then you 12, 5.
Okay, so she's borrowing, and 7 and 2. So that's how she got it, 2,700. Do you know, when you're finding the change between any two numbers, then it can be written the way she just wrote it, 15,000 minus 12,300, right? But it also could be written how? I have a big hint on the board. Do you see it, Bella?
You add the opposite.
Well, you could add the opposite, but that remains kind of the same statement. You could also find the change by subtracting the larger from the smaller. Isn't that interesting? And take the absolute, what is it? Absolute value. So this will give you the same difference as long as you are finding the absolute value. Changes some absolute value, okay? So the same is true for the distance between 2 points. I mean, if we look up at the number line above the board here and choose any 2 points, like let's choose 12 And somebody give me a negative. Grant, give me a negative. -2. So look at 12 and -2. And how far apart are 12 and -2? How far apart? Everyone say it?
14.
They're 14. So we can use the absolute difference between those 2 points to find that distance that you already know. I mean, how could we write that? Let's use 12 and -2. Notice I'm taking the difference between 12 and -2. We could also write it this way, -2 and 12. And let's just try, what is the difference here when we do both of these things? Pause this and erase it. So this is still subtraction. So Rachel, how could we rewrite the first one here? Rather than subtraction, what would we say? So what is it?
Plus 2.
+2. And what is 12 plus 2?
14.
The absolute value of 14 is 14. So we're saying the distance is 14. Let's try this one. Rather than subtracting 12, let's say together we would do what? Add what? Add -12, right? And so what is -2 plus -12? -14. And when we take the absolute value we have, the difference is 14. Isn't that nice? So if you're asked to find the difference between any two numbers or any two values, then as long as you take the absolute value, you can find the difference subtracting either way. Okay? It's really a good thing to remember. There you go.